All right, now we'll hear from Patrick Behrer. He is an economist in the Sustainability and Infrastructure team of the World Bank's Development Research Group. His work focuses on the economics of air pollution, climate change, and climate adaptation, and their impacts on human capital formation. His work uses big data from online sources and also from satellite remote sensing technology. And prior to joining the World Bank in 2021, Patrick was a postdoc at the Center for Food Security and the Environment at Stanford, and he received his PhD in 2020 from Harvard University in public policy. Welcome, Patrick.
Thank you, Jay. It's too bad that I couldn't be there in person, but very happy to do this remotely.
Happy to have you remotely. Yeah. So let's start off, Patrick, by posing the question, what are some of the knowns sort of around heat-related illnesses and the unknowns around increased accidents, perhaps decreased cognitive function of heat-related reduced productivity in the workforce? That's really what I want to focus on here. There's a reduction in the workforce due to increased heat. What can we expect? What forms do they take, and what are the associated costs?
Yeah, I think so. There are three areas in which heat will have adverse consequences for workers and reduce economic output via the labor channel. The first is direct impacts on productivity. There's a variety of ways in which that manifests, and I'll talk about each of them. The second is reductions in the amount of time that people spend at work. So we know from existing research from people like Josh Graf-Zivin, for example, or TWRN, that when it's really hot, people go to work less. On particularly hot days, they seem to reduce their labor supply by about 10%. So if you're going to work less, you're going to have less economic output. The third area is a more long-term consequence of heat exposure, but work that I've done with Ji-Sung Park and work that Josh Graf-Zivin has done as well indicates that exposure to high temperatures when you're in a classroom reduces the amount of material that you learn, and heat exposure has adverse consequences for long-run human capital formation. And we would expect that to have negative impacts on labor productivity and economic output in the future, particularly in an economy that is moving more and more towards high-skilled jobs that are cognitively demanding and require high levels of education to be successful. If you're reducing the amount that kids are learning today because of temperature, you're going to have an adverse effect that manifests in years in the future. Let me return, though, I think, to the first one that I mentioned, because I think that's probably the largest set of consequences at present. So that is the impact of heat on productivity. And that manifests in a variety of ways. The first is the obvious one, that when you go to work on a really hot day, you're uncomfortable, you're less focused, you just get less work done. And there's a variety of studies that show, using both aggregate outcomes, so total GDP numbers, as well as individual factory level, so individual worker level output, that shows when workers go to work on hot days, they just get less work done. And so that reduces economic productivity. Using some of the aggregate numbers, it suggests a 1 degree Celsius average, a year that is 1 degree Celsius warmer on average, reduces GDP by about 1%, or sorry, 0.1%. And so there are meaningful consequences to going to work on hot days in terms of reductions in output that reduce overall economic activity. The other way that heat manifests as a reduction in productivity, and I think this is sort of where you were going with the question, is it increases workplace injuries. This is a really important dimension of some of the work that I've done with Ji-Sung Park and Nora Pankratz using worker compensation data from the state of California. But what we have is the universe of worker compensation claims for nearly 20 years in California. And California is important because basically every worker in California is required to have worker compensation. So our data gives us the universe of workplace injuries in the state of California for almost 2 decades. And what we do with that is build on existing work in public health that has shown a robust relationship between heat exposure and negative adverse outcomes related to heat. So for example, you would expect that things like dehydration, heat stroke increase on hotter days. The public health literature has shown that is true, that relationship is very robust. What we wanted to do is combine that finding with some of the other work that we've done on the cognitive impacts of heat, because if you put those two things together, a sort of natural conclusion is that heat may have impacts on workers that go beyond just the things that are directly related to heat. So not only dehydration or heat stroke, but if you go to work and you're less focused and you work in a dangerous environment, you may be more likely to injure yourself because of that dangerous environment. And that's important because a lot of heat exposed workplaces, think agricultural settings, some manufacturing settings, construction sites, are at baseline dangerous places to work. And so if you reduce the amount of concentration or focus that somebody has in that baseline dangerous setting, it stands to reason that you increase the probability that they injure themselves in ways that might not be obviously related to heat. When we look at all of the data that we have for California, that's exactly what we find. So looking just at days above 100 degrees, you're 10 to 15% more likely to injure yourself at work if the temperature is above 100 degrees Fahrenheit. And that's the sort of looking at all injuries, not just heat stroke or heat syncope, but looking at things like falling off ladders, because you start to get dehydrated, you lose your concentration, you lose your balance, getting your hand stuck in a machine, the kinds of injuries that we might not think of as heat-related injuries, but are nonetheless consequential for workers and consequential for worker productivity. And so one of the lessons that we take away from this study is that if you look only at heat-related injuries, you substantially underestimate the total injury burden of heat in the workplace. We think that in the state of California, just looking at heat-coded injuries versus all injuries that we can reasonably attribute to heat, we think that the heat-coded injuries underestimate the heat burden by about 5 times. So there's a substantial undercounting if you're just focusing on the heat-related injuries. Let me stop there. There's other things I could say about that study, but see if you have follow-up questions.
Yeah, no, thanks. Yeah, the first follow-up question here would be, is this the case? I believe there's some recent data that this is also the case even for indoor jobs, things we normally would think everyone's in a nice air-conditioned environment and they're immune to these effects. But do you have any information on that?
Yeah, so we do find a gradient in jobs that we think are reasonably likely to be air conditioned. So for example, because we have a lot of information about the workers in our data, and so we can observe what kind of industry or what kind of occupation you're working in. And so if you're a finance professional, something that we think you're probably working in an office, you're probably highly air conditioned, the relationship between heat and workplace injuries is not very strong. But not all indoor workplaces are air conditioned or well protected. The sort of classic example of this is manufacturing. We think of manufacturing as an indoor job. It typically is. It occurs in some kind of warehouse or factory. It's very rarely air conditioned though. And so it is an indoor job that is highly exposed to heat. And so we find adverse consequences in terms of injuries for workers, even in these indoor manufacturing jobs. And that's true across the board. So being indoors is not simply a protection against this heat. This story isn't just about construction workers or agricultural workers who are sort of the classic, I guess in Texas, oil and gas and mining would be another big outdoor industry. But those are kind of the classic examples of outdoor occupations that people think of when they think of heat exposure and heat related injuries. Our data says that this story is much bigger than that because there's a lot of indoor jobs that you might think are protected from heat that are in fact not protected from heat because the workers are not working in a climate controlled environment, even though they're inside.
Right on, that makes a lot of sense, thanks. So this number you noted, 1 degree warmer per year reduces GDP by 0.1%. How can we use numbers like this to try to understand the impacts for, say, a given summer like 2023 in a given place like Texas?
So it's a little bit hard to use that number in a specific case like Texas's past summer. What we can say is that as the climate warms, if we fail to adapt, productivity will decline. And it is a lot of these studies find a non-linear relationship between productivity declines and increases in temperature. And so as you get to higher and higher and higher temperatures, you see larger and larger negative effects of those temperatures. The number that I gave is sort of an average across a lot of different settings. But if you start from a high baseline temperature and then you continue to increase that temperature, as you increase the temperature, you're going to see larger and larger negative effects. I think the thing that we can reasonably conclude is that climate change will lead to reductions in economic activity, absent adaptation. Now, there is some evidence that adaptation is happening. Hotter places in the United States see smaller negative effects of extreme temperature than non-adapted places in the United States. So for example, if you compare Houston and Boston, you see larger negative effects of temperature in Boston than in Houston. That's likely because air conditioning, for example, has a far higher rate of penetration in buildings in Houston, and it's also much more efficient in Houston than it is in Boston.
Interesting. So that means we're doing pretty good in Texas. We don't have so much to be concerned about, do we?
No, so I think Texas is one of the best adapted places to heat in the United States. I think that there's still a lot of damages that can occur even in these adapted places. And so one of the other things that we've looked at specific to Texas, this is work with Valentin Bolotny, is the impact of heat on criminal activity and also the impact of heat on how cases proceed through the criminal justice system. So we look at two things independently of one another. The first is how heat increases the commission of crimes. What we find is that heat has large impacts on people committing crimes. So on a day above 100 degrees, you're 10 to 15% more likely to commit a violent crime than on days between 60 and 65 degrees. The other thing that we look at is, because we observe the behavior of prosecutors, police officers, and judges, we look at how their behavior changes on really hot days, independent of the impact of heat on the commission of crimes. And I think one of the most notable things we find, particularly to your point about Texas being well adapted, is that heat has adverse consequences for judicial decision-making, even in the relatively well-adapted courtrooms in Texas. And so we find that when judges decide cases where the mean temperature is above 90 degrees Fahrenheit, so these are pretty hot days, they issue longer sentences, they issue higher fines, and they're less likely to dismiss the case. So overall, it suggests that deciding cases on hotter days makes judges more punitive than when they decide cases on less hot days. And this occurs in an environment, as I said, Houston, sort of Texas writ large, is relatively well adapted to heat compared to the rest of the United States. And yet you still haven't fully adapted away these negative effects. The other thing that we can do that speaks to this adaptation question is we look at how the impact of heat on the commission of crimes varies across different places in Texas that we believe are better or worse adapted, because there is variation across the state in adaptation. And then what we do is combine that variation in adaptation across the state with projections of climate change going forward out to 2050 and assumptions about how adaptation will evolve in the state. And what we find is that while adaptation helps, it only reduces the adverse effects of future climate change by about 25%. So adaptation will protect us from some of the worst consequences of climate change, but at least in our evidence, we don't find evidence for the claim that there's nothing to worry about or that adaptation will fully protect us from the adverse effects of heat.
Right on. Got it. So it's really fascinating data about judicial system, criminal justice, commission of crimes, etc. As climate extremes increase, say, like the projections for Texas tell us, that will be in a more permanent drought and high heat state in the second half of this century. If that becomes the new normal, this excessive heat, does this increase in violent behavior become normalized? In other words, will the increase of violence only occur when things are out of the norm, even though the base level of heat is higher, or will it just continue to scale upward?
So that's a tough question to answer, and I think it's an area of very active research. My best sort of guess or hypothesis about this is that we will continue to see increases in crime as the temperature increases, and some of that may be attenuated by either adaptation, so changes in the physical infrastructure, or climatization, so you get used to it being hotter. And there's some evidence that at relatively low temperatures, so say between 80 and 90 degrees Fahrenheit, athletes, for example, who train in hotter places, then do better when they compete. And so that's sort of evidence in favor of this acclimatization hypothesis. You get used to these hotter temperatures, and then you perform at a higher level when it is, in fact, hot. I think the limit of that research is that the temperature ranges over which they demonstrate acclimatization occurs are low relative to the extremes that we see. So in the particular study that I'm thinking of, they were looking at maximum temperatures that were in the high 80s, low 90s. Contrast that with maximum temperatures that you're seeing in Texas already in the 110s, the teens, maybe even the 120s. There's a big difference between temperatures in that upper range and the temperatures in the low 90s. And we see from other studies that the adverse consequences of heat across a range of effects, so injuries, violence, cognitive impacts, productivity, tend to be nonlinear. That is, they grow larger as you increase the temperature. And so you might, I think it is reasonable to expect that there are limits to the acclimatization hypothesis, that maybe we can acclimatize the temperatures up to, say, 100 degrees or 105 degrees. But as you start exceeding those temperatures, you start to realize the same adverse effects, even if you are used to, say, it being 100 degrees. And that's consistent with sort of the biophysical limits of the human body. There is a temperature threshold above which our body can no longer disperse heat. Now that's well outside of the range of the temperature ranges that I'm talking about. But there are limits to acclimatization. We know this just in terms of the biophysical limits of the human body. And so I think it's reasonable to conclude that there are limits in terms of these other outcomes that we're looking at: violence, cognitive effects, productivity effects, and so on.
Great, thanks. All right, last question. Given all of this, and here we are trying to sort of put an overall price tag, right? What are the costs economically for a state like Texas in looking at these heat and drought events? How can we put a price, do you think? What advice would you have as we go about the business of trying to put a price on all of these impacts for a specific event, the event namely being the high heat and dryness of the summer of 2023 in Texas?
Yeah, so I think there are sort of two ways that economists have tried to put a price on the consequences of heat. One is this top-down approach where you sort of start with a GDP number and you look at how GDP changes as a consequence of higher temperatures. That obviously leaves out all of the things that don't get counted in GDP, so human welfare effects, health effects, and so on. The other way that you can do it is try and start from the very bottom up, look at all of the individual components of the things that, for example, I study: the cognitive impacts, the violence, the worker productivity effects, and monetize those effects, and then add them all up to get an aggregate effect number. Ideally, when you would do both of those things and kind of come to a number that come to some consensus from each of those approaches. Each one is going to capture things that the other might not. But I think that there is a real benefit to, obviously, a lot of my work focuses on the micro side of things. And the reason for that is that I think there is a real benefit to focusing on that micro aspect of things, because there's a lot of dimensions of this problem of exposure to heat that don't get captured in economic statistics. So, for example, if you get hurt at work, there's some loss in productivity that will show up in GDP numbers or wage numbers or output numbers. But there's also a welfare cost of that to you as an individual dealing with sort of the pain and suffering of having been hurt. And that's not going to get captured in those aggregate statistics. And so when you do the micro approach, it gives you a better ability, I think, to monetize some of those other welfare effects. So we don't directly estimate the welfare effect that getting injured at work has for workers. Other people have put numbers on that, though, and you could imagine combining the estimates we have for the increase in the frequency of injuries with those monetized values of the welfare effects of those injuries to get an overall number. And then you could do that across a range of different things. So, for example, you could take our estimates of the increase in crime and do the same combination with other estimates of the welfare consequences of crime.
Great. Patrick, thank you so much for your time with us here.
Absolutely. Thank you. I enjoyed it.
Bye-bye.